The indices array defines each face like a pair of triangles, specifying each triangle's vertices as an index into the cube's vertex arrays. Thus, the cube is described as a collection of 12 triangles. So next you need to call this new function from the init buffers and return the buffer it creates. So note, at the end of the init buffer function, so at the end of the init buffers function, so we're gonna go into the init buffer function at the end, okay, of your init buffer module of your init buffer. So this, let me see, let's first look for the init buffer. Init, no, init it's gonna be init buffers, so it's gonna be the second one. This is the curly braces and that here, so this is the M. Okay, init buffer, so it's gonna be that one. At the end of the inner buffers function of your init buffers module, add the following code replacing the existing return statement. So okay, so let me see, so this is the curly braces is gonna end here, and this is the return statement, so we can just take it out and we're gonna replace it with this piece of code. So let me see, let's read it again. At the end of the init buffers function of your init buffer JS module, add the following code replacing the existing return statement. So we're gonna have a declaration here name, it's gonna be cons, but the declaration is gonna be index buffer, so we're gonna name it index buffer and we're gonna set it to something. So we're gonna set it to the init index buffer, so it's gonna be init, okay, init index buffer. We're gonna open parentheses and we're gonna pass in the GL, end it up with a semicolon, okay, and yeah, and now we're gonna return, so we're gonna return curly braces, so we're gonna return the position, so it's gonna be position colon, and it's gonna be position buffer, so it's gonna be position buffer, comma, we're gonna have the color, okay, and it's gonna be color buffer, okay, so yeah, color buffer, the second one, comma, and then we're gonna have the indices, so it's gonna be in the C's like that, no, indices, okay, like that, and then we're gonna set it to index buffer, and we can put a comma at the end. So we are updating that one, and yeah, we ended up this statement, this return statement with a semicolon at the end, and this is the update that we did for the function init buffer. So we have updated the return statement with this piece of code. We added a return statement plus this new declaration index buffer. Okay, so let's keep moving, so we're almost done. Now, drawing the cube. Next we need to add code to our drawSim function to draw using the cube's index buffer, adding new gl.bindBuffer and gl.drawElements call. So that's what we're gonna do, and your drawSim function. So now we're gonna close this one, and I'm gonna open the drawSim file. Okay, so in your drawSim function, add the following code just before the GL use program line. So GL use program. So what I'm gonna do is GL that program like that. No, it's not working here. Let me see. Oops. Let's open it, and just before the GL use program, so okay, just before the GL use program, GL use program here. Okay, so in your drawSim function, add the following code just before the GL use program line. So we're gonna go here and between the set position, no, here, before the GL that use program. So we're gonna have a comment here. It's gonna be let's just copy the comment here and just have it for our file. So it says tell WebGL which indices to use to index the vertices. So we're gonna use the GL that bind buffer. So now we use the bind buffer, and we're gonna pass in some parameters. It's gonna be the GL that element underscore GL that bind buffer GL element. Okay, it didn't do that automatically. Okay, that's fine. Underscore buffer, and as a second parameter we're gonna have in the buffers that it's gonna be buffers that indices. So it's gonna be indices. Okay, it's gonna be indices. Okay, and we can end it up with a semicolon here. Okay, that's fine. Okay, so let me see. So we have the GL that bind buffer, GL that element underscore array underscore buffer, and then we're gonna have buffers that indices. Okay, that's fine. We are almost done. So and the draw scene function of your draw scene JS module. So let me see, and the draw scene function. Let me see the draw scene. This is the draw scene function. It starts here and it ends right here. Okay, so we have that. Okay, so let me see. Of your draw scene module, replace the black just after the two GL uniform matrix for FB calls that contains the GL.draw arrays line with the following block. So let me see. They're talking about the model view matrix. No. Okay, so let's open it here, and let me see. It's gonna be this one. Okay, should be up to this point also. Okay, we have two GL that uniform matrix for FB. Okay, so it has to be here. So let me read it again. And the draw scene function of your draw scene JS module replace the block just after the two GL uniform matrix for FB calls that contains the GL.draw arrays line with the following block. So we are updating the GL.draw array. So okay, so we have 1, 2, and we are gonna update this. Let me see if we are updating the whole thing. So they're talking about line 74 in this case. So it's gonna be GL.draw arrays. And let me see, let me read it again. Replace the black just after the two blah blah blah. So this one, so they're talking about this whole block then. Okay, so we are gonna replace it with counts. Okay, we have vertex count, we have the offset. Okay, so yeah, that contains the GL.draw arrays line with the following block. So we are replacing the whole block, and yeah, let's just pretty much delete it, and we can open curly braces again. Yeah, and then we're gonna have this constant declaration. We're gonna name it vertex count. So it's gonna be vertex count. Okay, we are updating it. So the vertex count is gonna be set to 36. The next one, we're gonna have the variable declaration name type, and we're gonna set it to the GL dat, and it's gonna be unsigned. So let me see, unsigned. unsigned. No, I don't have it here. It's gonna be short, semicolon at the end, and then we're gonna have another constant declaration. This time it's gonna be named offset, and we're gonna set it to 0, semicolon at the end, and finally we're gonna have the GL dot draw elements. We're gonna pass in these parameters. Is gonna be GL dot triangle, so it's gonna be triangles, and we're gonna have the vertex count, so it's gonna be the vertex count, and also we're as a the third parameter is gonna be type, and the fourth is gonna be offset. So semicolon at the end, and let's just give it a quick review. Vertex set to 36, type set to GL dot unsigned underscore short, offset set to 0, GL dot draw element set to, well, we're passing the parameter GL triangles. Okay, vertex count, type, and offset. So we have that. Okay, so we did that, and we can just close it. And now, okay, so now it's moving, it has updated, so we have this cube and it's rotating from right to left, as you can see. Well, depends of your point of reference. Okay, so since each face of our cube is comprised of 2 triangles, there are 6 vertices per side, or 36 total vertices in the cube, even though many of them are duplicates. Finally, let's replace our variable square rotation by cube rotation. So we have before the square, now it's going to be a cube rotation, and add a second rotation around the x-axis. So to do that, at the start of your WebGL demo.js file, at the start, so let's open it, this one. Okay, so let's go way to the start. We're gonna replace, okay, at the start of your WebGL, replace the square rotation declaration with this line. So okay, so instead of having the square rotation, we're gonna have cube rotation, and instead of setting it to 0, okay, so we're gonna let it to 0, and let's save it. Okay, so up to this point is still, let me see, cube rotation set to 0, 0. Okay, that's fine. Now, and your drawing function declaration, and your drawing function declaration. So we're gonna close the main one, or the WebGL, and we're gonna go again to the drawing. Oops, we're gonna go to the drawing function drawing, and your drawing function declaration, replace the square rotation with cube rotation. So let me see, cube square rotation, let me see if I can do control F. Okay, I can do, and then a square, okay, it's gonna be a square rotation. Okay, so now we have that one, a square rotation, we have the square rotation, and also we have okay, so and your drawing function declaration, replace the square rotation with cube rotation. So let me see, and also probably we're gonna also change that one, but let's go for this one first. So let's close here, and we are in the line 1, the function drawing. We have 4 arguments, and the fourth argument is a square rotation, so we're gonna update it to cube rotation. So I'm gonna save it. Okay, so we have, let me see, drawing, we have GL, programming info, buffers, and cube rotation. Okay, that's fine. Now, and your drawing function, replace mat4 rotate call with the following code. So in your drawing function, okay, so it's in your drawing function, we need to replace the mat4, replace the mat4 that rotate, so mat4 that rotate, so it's gonna be this one, mat4 that rotate. okay, with the following code. So oops, yeah, this is gonna be a little bit, so let's just delete this whole thing. So we are pretty much updating this mat4 from line 40, so I'm just gonna delete it, and I'm gonna type in again, it's gonna be mat4 dot, well, it's gonna be mat4 dot rotate. Okay, so we're gonna open parentheses, and inside of the parentheses we're gonna have the model view matrix, comma. Okay, so the destination matrix, we're gonna have the model view matrix again, and it's gonna be this time the matrix to rotate, so model view matrix. Then we're gonna have cube rotation. Okay, so yeah, we updated, it's gonna be cube rotation, comma, cube rotation, amount to rotate in radians. Then we're gonna have this array, it's gonna be 0, 0, 1. Let me see, 0, 0, 1, that's fine. Okay, comma again at the end of the array, and we're gonna end this mat4 that rotate with a semicolon. Okay, axis to rotate around the z coordinates. So we have the mat4 that rotate, and okay, we're gonna have again another mat4 that rotate. And okay, so since I already copied, one thing I can do is pretty much just copy this whole thing and move here, and I'm gonna have another mat4 that rotates, so they're pretty much the same. Model view matrix, cube rotation. So here we're multiplying it by 7, so this cube rotation asterisk, and let me see, I think it was 0.7. okay, 0.7 comma at the end, and then we're gonna have in the array we have the numbers now 0, 1, 0, so we can save it up to this point. Let me see how it's okay, nothing yet. We have that axis to rotate around the y coordinates, and now we're gonna have the final one. Okay, so and again, this is like calculus 3 or calculus of several variables, so we're gonna have the cube rotation, and the cube rotation this time we're gonna multiply it by 0.3. Okay, and now we're gonna have the matrix is gonna be the numbers 1, 0, and then 0 again, so we can save it. And this is the axis to rotate around the x, so we have that. Okay, so note, in your main function replace the code that calls drawSym and updates square rotation to pass in and update cube rotation instead. So we are done here with this file, and now we're gonna go into our WebGL demo. Let me see, in your main function replace the code that calls drawSym. Okay, replace the drawSym. So we are here and just gonna press Control F, and I'm gonna type in drawSym. So this is the function that it calls drawSym, so we are updating it. Okay, let me see, and updates square rotation, to pass in and update cube rotation instead. Okay, so yeah, the only thing that we have to do pretty much is do this cube rotation. So this is the update, and and also obviously we have this one is gonna be cube rotation, so it's gonna be cube rotation, and here we have the assignment, the assignment operator. So pretty much cube rotation is assigned or is equal to the cube rotation plus the delta time. So let me see how it's okay. As you can see, it's working. So this is our final product so far, and as you can see, it's pretty cool. So it's rotating around the axis, 3 different coordinates, around the x-axis, around the y-axis, and around the z-axis. So that's what we have here. And let me see if we need to update something else. So at this point we now have an animated cube rotating at 6 faces, rather vividly colored. So yeah, we have the same thing, and you can check out the complete view here. And yeah, I mean, that's pretty much all that we have for the creating 3D objects using the WebGL.